Hello, everyone. It is Thursday, March 4th. My name is Drew Sukup. On behalf of VMUG, I'd like to welcome you to today's Expedient webcast. Automate at scale with Expedient. Oh, forgive me. Hope you didn't hear that. It's me listening to myself. On behalf of VMUG, I'd like to welcome you to today's Expedient webcast, Automate at Scale with Expedient Enterprise Cloud, presented by AJ Kuftik, Principal Technologist at Expedient. Thank you for participating in today's webcast and for your continued support in the Global VMUG program. Before we begin, I have 3 quick housekeeping items to go over. First, today's webcast will be recorded and available for you on demand. You'll receive an email with the on-demand link, so keep an eye out for that tomorrow. Second, a short Q&A session will follow today's presentation. All questions will need to be entered into the question and answer section on the side. Please feel free to ask questions throughout the presentation. I'll try to answer any VMUG related questions throughout, but we're going to save all the questions for AJ to the end. Third, there'll be a short online evaluation that pops up as you exit the webcast. Please take a minute and let us know what you thought of today's session and what you might like to see going forward. All attendees from today's webcast who opted in their information at registration will be entered into a raffle to win a Bose Sound Link. The winner will be contacted directly by Expedient. So good luck. All right, let's get started. AJ, I'll turn it over to you now.
Thanks, Drew. Hi, everybody. My name is AJ Kuftik. As Drew just mentioned, I'm Principal Technologist with Expedient, and I have a tickle in my nose. I feel like I'm going to sneeze. As a quick, kind of recap of who Expedient is, we were founded in 2001. We started in co-location, moved into managed services, and are now in cloud. We have cloud locations US East, Central, and West, so we cover the entire US. And we have international cloud deployments on customer sites in Australia, Germany, and Canada. So if our cloud locations don't work, we can bring that cloud to you. And that applies domestically as well. We're a VMware Cloud provider and have been since the program's inception in 2007. We have tens of thousands of virtual machines supporting over 1,000 customers. So if you have 2 VMs or 2,000 VMs, we can meet those needs. And I know that you're all here to hear about automation and automating at scale, which is super cool and super fun. And we have a really neat demo to show you here in a second. But before we talk about that, we kind of have to talk about work. And really, one of the problems that we run into with work, besides having to be here and do it, is that all of the work that we have doesn't match up with the amount of time that we have, right? And our work can kind of be broken down into 4 general groups of options, right? The first is business projects. These are the things that provide top line revenue, new features, all of the really cool stuff that we think as IT people that we do for a living, right? The whole reason that we exist is so that when the business has deep technology questions, they come to us and they ask us to answer them. And that's a good part of what our job is, and that's what we should be doing. But it's not everything that we do, because not all business projects actually meet what we do as IT to make sure that the lights stay on. For that, we have things like internal projects. These are things like architecture changes, so going from 3-tier to hyper-converged, on-prem to cloud, VMs to cloud native, any of these sorts of architecture projects that may not have a direct bottom line revenue or top line revenue sort of generating feature. They are more, maybe their cost savings to help the bottom line or their availability, right? We want to make sure that the business is up as much as possible, and we're changing architectures to increase the amount of availability. Automation also fits into this. Automation from an overall standpoint, you have you need to spend the time to actually go write all this code, to actually go connect everything together, to make sure that it all works, but you have to spend the time and allocate the time to doing that. On the bottom, we have our 2 works. First is unplanned work, and that is exactly what it sounds like, right? This is the work that isn't planned. This is things like code defects where, code was written and it goes into production and some downstream service doesn't realize that change has happened and now it's broken and now somebody has to go fix that code. They have to do a bug fix to fix a bug fix. Seems very weird, but it happens quite often. And then there are just the general problems, right? We're all familiar with VMware, hosts go down, networks go down, storage goes down. Any of these sorts of things that happen on the infrastructure side were problems that are just not planned, right? You can't say, oh, you know what, each day I'm going to spend about 95 minutes working on problems. No one does that. They're dealt with as they happen, right? If a hose goes down, you have to go take care of that issue. And then finally, we have planned work. And these are the things that we know about now that we're probably going to do next year. Things like we patch every month. That doesn't change year to year. That doesn't change quarter to quarter. Your patching happens on your patching schedule. Your hardware refreshes generally happen on your schedule, right? You know that you bought this piece of hardware in 2018. It has a 3-year life cycle, so you're probably going to be replacing it this year or next year, depending on budgets and those sorts of things. But you know your general planned work way, way far in advance. If we group these ever so slightly in slightly higher groups here, the business projects and internal projects, this is high value work. This is what we do day in and day out that we know is providing deep value to the business, whether it's directly into the revenue or profit of the business or into our ability to deliver our services to the business, right? This is high value work. This is what we get paid the dollars to do, right? Or your local currency. On the bottom, this is low value work. This work that's not planned, not really, or planned or unplanned, this work that we do is all the things that we do to keep the lights on. And when we think about this, it's kind of like thinking about literally keeping the lights on, right? When you flip the light switch in your room, you expect the light to turn on. When you flip that light switch, you're not thinking, okay, when I flip this light switch, it goes through a wire that goes up into that light. That light then turns on. On the other side of the switch, it actually goes down to the breaker box, which is connected to the main power feed. You don't think about any of that. You just think switch up, light on. And that's what the business wants out of IT. They don't want to have to think about all the individual things. They don't want to think about the wiring in the wall. They're just worried about how bright the lights are and how quickly they turn on. So what we need to do is turn our low value tasks into high value work. Now, obviously we're still in the middle of a pandemic, but a lot of people got into baking. I am no different, right? And I started baking a lot of bread, mostly because it was interesting to do. It was a neat skill to learn, but I also got really, really into what I need to do to make my bread better. And I can make 1 to 2 loaves of bread every week. And that's it. That's the scale. That is it. But in order to do more, I would have to either A, quit my job, which don't really want to do, but also I need to build more time into my schedule to work on this. I actually just this past weekend tried to make croissants, or croissant, if you would like to pronounce it properly. And it took 3 days. You make the dough one night, you do a bunch of shaping the next day, and then you bake them on the morning of the 3rd day. That's a lot of time. And how many did I get? 12. 3 days of work, 12 croissants. So how do we actually do this? Why do we want to turn low value tasks into high value work? By automating these sorts of things, we can gain new capabilities. If I wanted to make more than 2 loaves of bread, I need to figure out a better system on how to make my bread more consistent. How do I make the same 2 loaves that I make today? How do I make 4 or 8 or 12 or 16 or 20 loaves and have them all be the same every single time? In order to do that, you need to standardize. The recipe has to be set and it needs to be made the same way every single time. Now, I am a human being and I sometimes make mistakes. Sometimes I put in a little extra flour. Sometimes I put in a little extra honey. Sometimes I put in a little extra salt. In 2 loaves, that's not that big of a deal. But over the course of 20 or 40 loaves, that could become a big, big problem. And I don't get the consistency that I want, and I may have losses in the number of things that I'm baking. In the IT world, when you you cannot automate snowflake processes. And what I mean by that is you can't say, okay, every time I build this server, someone has to go in and manually touch this server to apply an IP address. That's not automating. You're automating a lot of it until you get to a point, and now we're adding in challenges to getting to the consistency and scalability that we want. Because what we're aiming for is time savings. I don't want to spend all of this time where I'm building out this platform and automation just to burn it waiting for Bob to go in and apply an IP address. That doesn't save Bob his time. That doesn't make the user experience or the developer's experience any better. And I just have like this really convoluted process for deploying a virtual machine. The other thing we're looking for here is scalability. Because if you can build in all of this consistency and all of this standardization, there's no difference between making 2 versus 200 versus 2,000. That process scales linearly and you're able to automate at scale, right? So instead of making 1 or 2 loaves, I can make 200 loaves. I need a way bigger oven. So, I'm going to have to do some sort of addition on my house to get an oven like that. But if I wanted to do this, this is what you would have to do. So the problem, though, is that when we hit scalability, we run into big scaling challenges. And there's a lovely piece called human wait time. And this is all of the times in your process. And I want you to think about that. Think about your processes that you have today, where a human has to be involved in the process. And that may be things like manual inputs, where when this server gets deployed, somebody has to go in and type in the name of the server. Or when the server gets deployed, someone has to go add in the IP address, or they have to install some agent, or they have to do some piece manually. And when these manual inputs happen, it creates human wait time and your process just gets bigger and longer. The other side of this is manual checkout. This is what I like to call trust issues. Every time you add in a manual checkout, the process is complete, but it's not released to the user, the requester, the whoever to actually be used. You have somebody in there going, okay, did this work? Did this software work? Did this actually get deployed properly? And when you add in these manual checks, while good from a quality standpoint, it's terrible from a turnaround time standpoint. And all of this human wait time creates challenges to you being able to scale. You can't go from 2 to 200 when someone has to go check out all 200 or someone has to go put in 200 IP addresses. It doesn't work. So think about your processes before you even get into code or tooling or anything else. Think about your process and where are your human wait times? What are the non-automatable pieces currently that you have today? And then what needs to change to do that going forward? Maybe instead of having somebody come in and apply an IP address, I use something like an IP pool, or I use DHCP with DHCP reservation. So I can get what I need, which is an IP address, into the system without having to wait for a person. And then I can set up my guardrails around that to say all of my servers are landing on this specific network, or they're landing in this particular cluster, let's say for licensing purposes, in order to make sure that I don't have to have anyone look at this. If someone goes through and their workflow gets approved, done, and I'm off to the races. And in the next 20 minutes, I have something to work on. So once you think about all of your processes and you build all of those and create a task that is automatable, we need to turn them into code. And that starts with something like HashiCorp's Terraform product. Terraform is really, really great at creating a predictable workflow, and to the point where you literally can do a predict on what will happen. So you can build in your configuration inside of Terraform. You create a Terraform file and it has the configuration that you're looking for. And when you actually go run it, it will tell you exactly what it's going to do. So it will say, hey, when you do this, I'm going to delete this VM and create a new one. Or when I deliver this, I'm going to do these installs, these adds, or there's no actual change because this is already set. This already has an IP address. This already has this configuration. I don't need to make any changes. You know exactly what that's going to do the moment that you actually run it. It's also super extensible. So I can do things with Terraform, not just with my VMware stack. I can do that with AWS or Azure or Windows or Linux. And I can use this tool to start to build my task into code, that infrastructure as code, across my platforms. This is where you can really get in deep with your developers to say, hey, How can we help support you going forward? You want to go build out your own infrastructure. Okay, let's work on the Terraform file that actually has your configuration in there correctly so that we as the infrastructure team know that you're developing everything and doing it the same way every single time. Right? This is the olive branch between the two sides. And finally, this is all versionable. So I can have my Terraform file sitting in a GitHub account or a GitLab account or Bitbucket or whatever your code versioning system might be. And I can have that and be able to go back very, very quickly if a change is made that doesn't work. So let's say I update my Terraform file and that deployment doesn't work anymore. Whoops, go back to version 1.3 that does work and do a redeploy off of that. So I can have very quick turnaround times on improvements and changes without saying, well, no one took a backup of that file. We'll never know what happened after that. So now that we have this config deployed onto a system, how do we manage this? And that's where a tool like Ansible comes in. Ansible is a really, really great tool. It's free and open source for the basic version. Red Hat sells a version, the Ansible Tower, that's very good at doing things, kind of at scale. If you're in the mid-market, small enterprise, Ansible Tower is a really, really great investment. But what it allows you to do is to prevent configuration drift. I have dropped a configuration on a machine. If I go in and I open up some different port and the configuration specifically says, don't do that, Ansible can run against it and reshut that port down. So let's say I don't want SSH enabled. Well, that's a terrible example for Ansible because that's how it works. But if I have, say, FTP open and the configuration specifically says do not have that open, it can go back in and turn that port back off. This provides you with the ability to make sure that your configuration is consistent across the board. Because what we want is the ability to make consistent changes. I want to know that when I go out, this playbook is the same and will run the same on every single server that it gets pushed out to, every single instance that I push it out to. That consistency in your change is a magic audit superpower. I know that change control is not exactly the most fun topic in the world to think about or talk about, but it's incredibly important. The reason we have things like change control is because things have gone wrong with no notification based on something that someone did. And so by having a good change control process, you can help eliminate that. The problem with change control is that a lot of people look at it as paperwork that they don't want to do. With something like Ansible, you say, here's my change. It's all in there, human readable. And here's the last 50 changes we made with Ansible, and they were all consistent. And I can push that out and get a report back that says, here's all the ones that work, here's the ones that didn't, and I can go troubleshoot the 3 or 4 that didn't. It makes it easy to handle audits when they say, what's your configuration and how are you managing drift? Oh, my configuration's here in Terraform, here's the file, and here's Ansible making sure that it stays that way. That is a massive superpower that I think a lot of people miss when they're looking at things like when they're in the middle of their ISO audits or HIPAA, high trust, SOC audits, is being able to say that their configuration is the way that it is in their documentation. So now that we have this, this ability to deploy a config and manage it, how do you deliver it at scale? And that's where our Enterprise Cloud comes in. Our Enterprise Cloud features a fully functional REST API that developers and Terraform and Ansible can all utilize to be able to deliver a consistent platform at scale. And that's a big deal. I think a lot of times when people think about their infrastructure, they don't think about how their developers can talk to it. They think about how they can automate it from the infrastructure side, can automate it from a deployment standpoint or maybe a patching standpoint or even a configuration standpoint. They don't think about how, hey, I can actually present this to my developers and have them use it too. And all of this is managed. So you don't have to figure out what the interoperability is between vCenter and ESXi and how my applications are going to work on the platform. We take care of all of that for you. This is time that you actually get back in your day, get back in your schedule, so you can focus on the things that matter, like automating on top of it, or how your workflows can make your business faster by being able to deliver them a platform that works much, much quicker and at scale. We want to be able to scale with you. So when you need more resources, you get them. And I'm pretty sure that if we were all in person and this were a very nice VMUG user calling in person, I could probably say, hey, how many of you have a good relationship with your procurement department? And I wouldn't see too many hands go up. A lot of that has to do with the fact that it takes a very long time to get things through that process beyond just waiting for the hardware to show up and arrive and get racked and cabled and configured and deployed and ready for production. By that time, the developer's like, I moved on to a different idea. It takes a very long time. When you need more resources with Expedient Enterprise Cloud, you make a phone call, you get more resources, and off you go. You don't have to wait for it. We can deliver them very, very quickly. So you can get them back to your developers before they get distracted and move on with a better idea. So I mentioned a demo. We're going to go through a demo. What I'm going to do is I'm going to push some code from Visual Studio Code up to GitHub. Jenkins is going to watch GitHub, and it's going to say, hey, I see a new build. And then it's going to use Ansible and Terraform to build a WordPress site on top of Expedient Enterprise Cloud. It's a really neat demo, and all of this code is actually available on our GitHub site. But let's dive in to this demo. Real quick first, though, I want to show you some of our API documentation. You can go to this as well, api.docs.expedient.cloud. You can see the same API calls, the same API code and workflows that we use in our environment today. Our own engineers use these to deliver a developer level or a developer style workflow that goes on top of it. I'm just going to move that over so it's not distracting. So we can start with things like environment setup, and I can click on login, and I can see this is the REST API call using curl to log in, right? And I have the example code here that you can use and what the response should be that you get back. But we also have things like VApp and VM, so we can do a bunch of get commands. We can even do posts, so we can create a VApp and VM, power on, power off, and even deletes. So you have a lot of capability in here to let your developers do the things that they need to do. Or maybe you don't let them have access to all of that, like say deletes, and you let them just do creations as they desire or see fit. But let's say I'm not a curl, or I'm not a Linux person, maybe I'm more of a Windows guy, right? I can go and change this exact same command into PowerShell, invoke REST method, and I can do the same command, the same function, but do it through a different language. This is actually a really powerful tool that we have that runs in Postman. If you're familiar with Postman, it's a API management tool. So you can click run in Postman. It downloads all of the environment variables to get you set up, and it downloads all of these preset calls. So you can just pull them directly into your workflows and helps you get started very, very easily with our API documentation. But let's get into the demo here. So this is our Expedient Enterprise Cloud. This is based on vCloud Director. And I have two data centers here. I have our ACM data center that's in our Pittsburgh data center, and one of our Pittsburgh data centers, and 701 that's in Indianapolis. I'm going to open up Visual Studio Code here, and you can see that I've got this YAML file. This is an Ansible playbook. And inside of this Ansible playbook, I have a number of things that are pre-built and preset so that you as a customer can come in and take this on and do really, really neat things with it. So what I'm going to do is I'm going to kick off a deployment. And this is the Terraform file as well. So in here, I have what we actually use to connect to vCloud Director to actually do the deployment itself. We'll get into this a little bit deeper here in a second. So what I'm going to do is I'm going to change this to EEC. And I'm going to go up here to my source control, and we're going to do a deploy, and we're going to do a commit, and I'm going to do a push. So what I've done here is I have just done a push of this code up to GitHub, right? So we already had it pre-connected, so we don't need to jump through that. But here I have my automation demo, and this is a CICD pipeline. So this is what developers use to actually go push their code into production and manage their changes. So right now, the weather on this is a little cloudy, mostly because when we were building the demo, it got a little funky, had a lot of work to do, but it works. And what we have is our repository. What this repository is pointed to is this GitHub account. So if I click scan repository now, I'm just kind of telling Jenkins to go do a check. It does it automatically, but I'm just making sure that we keep time moving here. And I can scan and see that there were branches were processed and we're all finished examining it. And I can open Blue Ocean and I can see the actual status of the deployment. And when I go in here, I have 3 steps in this Jenkins build. I have Ansible in it, which says, hey, Ansible, you're here, right? Make sure that Ansible is running and downloaded and in place. I also have some prerequisites loaded into that. So I have things like some of the images or some of the playbook tools that we're going to end up using, things like MySQL, are all in there as well, the prerequisites that we need. That's all part of that Jenkins file. I also have Terraform in it, which makes sure that Terraform is loaded and ready to go, and it's pulled in a config. And now this Ansible playbook is running. So if I open up this Ansible playbook, I'm doing a Terraform deploy to EEC. And if I go into my ACM environment, and I click on vApps, I can see that I have 2 vApps that are currently deploying. One of them is the app server, one of them is the database server. So if I go back into my Visual Studio Code, I can see my Terraform file. In here, I have my VCD provider. In Terraform's language, this is effectively the connector between Terraform and vCloud Director that is translating those API calls. So the ones that we just talked about earlier in those API documents. You don't have to go learn how to write to all of those API calls. You can use Terraform to more or less obfuscate that and have a standardized language to work off of instead of trying to figure out every single API call to every single thing in your environment. It's one of the really great parts of Terraform. They figure all that out for you. But we have a VCD provider, and in here I have user, password, org, VDC URL. All of these are in a variable file, so they're all stowed away. They are not in the Terraform file itself. And if I scroll down, I start with my vApp and my WordPress app that we have here. So we're going to create an app and a DB. The first one is an app. We're going to deploy Ubuntu 16.04. We have 4 gigs of RAM, 2 CPUs, and we're going to do an init script here of the name server. So we're going to set up DNS and echo in an RSA key that Ansible will use to do the configuration inside of the VM. At the top here, I have the IP addresses that we'll end up using. So that's this 209.166. Those are the IP addresses that we'll use so that we can access this in the end. Down here, we have the database server, same thing, same Ubuntu 16.04, same size, same init script. But they're given a metadata of a role of DB, a role of app server. And that's what Ansible uses to know what to deploy on what server. And finally, at the end here, it'll all kick this out and kick out all those IP addresses so Ansible knows what to go talk to. So let's go check this out. I can see that they're stopped and they are now powering on. And now I can see that Ansible has picked up and now is waiting for these VMs to come up. Once these VMs are now up, it will start to do the deploy on the machines themselves. So Ansible will reach out to these servers and it will start to walk through this playbook. So the first thing we're going to do is we're going to set a pair of facts. So one is, this is the database server, this is the application server, so we know which is which. And then we have a 90-second timeout waiting for this provisioning to complete to make sure that we're all good and everything is in the place where it needs to be. We're going to run apt update to make sure that all of our packages are up to date and that we're getting the latest packages pulling down. Then we're going to configure the database. So this is going to deploy MySQL onto the database server, create a database, create a user, and then give it the privileges that it needs to actually go forward. Then we're going to install an app server package. So WordPress.app. This is going to deploy PHP, the MySQL client for PHP, and Apache. And then it's going to go install Apache, set up all of the features of it, so SSL load, rewrite load, and set what Apache should be listening on and where the web server file should land. And then finally, it's going to drop in WordPress, set up the accounts, even set up things like the theme so that we have a ready-to-go WordPress server when we're done. So if I go back into Jenkins, I can see that MySQL is deploying. It's actually doing the creation of the database, installing MySQL, and all the libraries are installed. And it's loading, and it's loading, and it's loading. There it goes. So we're already now done. WordPress is now done. So MySQL took its sweet, sweet time. Everything else installed pretty quickly. And WordPress is now created and up and running on this platform. And now I have a big green. We love the color green here. So we have a successful deployment. And if I go out to this web server and open this up, I can see that I have my example WordPress server. That's pretty great, right? We deployed, to EEC in about 5 minutes with a config file. All of this is versionable, and my developers know what they're getting when they hit the deploy button. But here's the thing. Automation's really cool. But one of the challenges that our developers run into is that they want to do things across cloud. They want to be in this multi-cloud sort of world. And one of the things that we at Expedient are doing are trying to help customers accelerate that cloud journey, right? And one of the challenges that a lot of customers run into from a multi-cloud management standpoint is they build all of their automation to work against one. They build it to work against whether that's our cloud, whether that's AWS, whether that's Azure, and they don't think about how their code could get deployed pretty much wherever. So what we did here is we actually built this file to not just deploy to EEC, but to be able to deploy to AWS as well. So all I have to do here is change this target environment to AWS, and we'll hit the go button here. And so now we've just done this commit to GitHub. Whoops, got to do a push, commit, then push. So when I go back here, I now have an AWS Terraform file. And we'll talk through this here in a second. But what I'm doing here is we're actually deploying to AWS. We're going to deploy to a pair of EC2 instances here, these two AMIs. And we're going to set up all of the security groups needed for the two of them to talk to each other and to talk to the internet. Again, all of this is inside of a Terraform file. Ansible is going to deploy the code the exact same way. All we're doing is saying, hey, instead of talking to EEC to get the infrastructure in the first place, talk to AWS, and here's how to go deploy a pair of AMIs as well. So if we go out to here, and I close that, I can see, again, this picked up the automated, I didn't have to tell it to go do it, it actually saw it this time. We're going to deploy to AWS. So again, we're initializing Ansible, initializing Terraform, everything's up and running, but instead of deploying to EEC, we deploy to AWS. So the AWS instances are already deployed, and we're already into the Ansible part. And this is rolling right along. And if we go out to the AWS Management Console, I can click on the EC2 Management Console here and go into my running instances. And I can see that I have a I have a T2 small and T2 medium instance that's been built out to do all of this deployment. I believe the medium is the database server, the small is the app server. If I go back to Jenkins, I can see that my deployment is now complete. And I can click on my T2 small, and we can go ahead and copy this to the clipboard. So now I've got this DNS entry. And if I paste this, I get the exact same example app server. So the app server is deployed. It was deployed the exact same way that it was deployed into EEC, but I was able to use that same code base across them. This is part of that multi-cloud management. How do you deploy your code to wherever you're going? And then how do you make sure that it's all being protected? We are in the process right now of deploying our new MultiCloud platform. So if you go to expedient.com, you can see how we're helping our customers cloud different with our multi-cloud management. I'm not going to get into that today. We can actually, if you have questions about that, please ask away. But we can get into how this is actually being deployed and being managed in a second. So that's the difference between EEC and AWS. We can deploy to wherever. But why would you want to use Expedient Enterprise Cloud? Expedient Enterprise Cloud is a VMware-based, VMware-powered platform. This enables faster migrations because you can take, and there's no app refactoring, you can physically lift and shift your workloads into our data center. Now, why would you want to do that? A lot of people say that lift and shift is a not great term to use. And that's fair. That's a completely fair statement to make. But when we're doing this because not every application fits into hyperscale. Not every application fits into the way that you would do things, right? A hyperscale world wants you to be able to spin things up and spin things down and only pay for what you're using. Your commodity off-the-shelf software may be sitting there running all of the time and taking up a lot of resources when they're not actually really doing anything, or when no one's getting any actual, value out of using that application. So by being able to land that on our cloud, we're built to run all the time. We have a predictable cost model based on pools of resources, so that you have the capability to have guardrails around the amount that you're spending. One of the challenges, again, of hyperscale clouds is that when you use them and you forget to turn things off, which happens a lot, there's many, many stories of this happening, where you forget to turn something off, and now you're spending a bunch of money on something you didn't expect to spend on. And that spend can be very spiky. And that's even before we get into things like egress fees. Our cloud does not have egress fees. So if you want to get into a cloud operating model, an OpEx style model, without the problems of spiky workloads and egress fees and trying to forecast that all through, Expedient Enterprise Cloud is a great way to do that. We also offer a 100% SLA, meaning if your services are down for whatever reason, there's a service credit for that. We want to make sure that you are up and running and that your experience is as good as it could possibly be. We design everything to enterprise best practices. We have N+2 across the platform and have a white glove service from our delivery team and operations support center teams to make sure that you're getting the support and migration help that you need to be successful in our cloud. We have 300 technical folks on staff that are building new products and supporting the current ones and making sure that our customers are the happiest in the industry. And finally, when you want to go do the hyperscale cloud things of the world, we have our cloud on-ramps. Our cloud on-ramps are our high-speed, low-latency connectivity through the Equinix fabric that allows you to connect into Azure, AWS, Google Cloud, so that you have super fast, low-latency connectivity to those services so that you can utilize them for the right workloads. We also have, as you guys saw, the API docs, so we can be fully API driven. And we also offer Kubernetes support with our partners at Rancher so that we can not only build your cloud native applications in our data center, but manage your Kubernetes clusters wherever they may be. If that's in your data center or Amazon EKS, Azure AKS, Google GKE, we can manage those platforms there as well, because we want to help you across this journey regardless of what it may be. Remember, we started as a colo provider. We still do that today. So if you have legacy physical workloads, you can land them in our data centers. Our enterprise cloud supports tens of thousands of VMs, so we can meet your needs from a cloud standpoint. And then as you're building your next generation applications with cloud native, we can do that and help you manage all of your hyperscale platforms and bring all of that visibility together. So it's not just our enterprise cloud, it is the Expedient experience. And if you want to get some hands-on experience with our enterprise cloud, you can reach out to me, aj.kuftik@expedient.com, or go to expedient.com/VMware-test-drive and sign up for a free 30-day trial. You get 128 gigs of RAM, a terabyte of storage, portal access to the environment. And if you want to just talk and dig deeper on what this could mean for you, again, reach out to me and we can figure out a way to schedule some time and talk through all of that. And with that, I'm going to open it up for questions. We're going to see if there's any questions out there.
Yeah, AJ, you're not going to believe it. You've done such a great job at explaining everything that no one has had any questions yet. But please, if you have any questions, now is the time to ask, because me and AJ are here for a little bit longer.
That's absolutely true. I don't know. Drew, is there a way to do a poll? Can we do a poll?
Oh, no, only a pretty advanced poll. Sorry about that, AJ.
No, that's all right. Hey, real quick, throw in a question. This isn't so much a question as a comment. I know everybody loves those. Tell me how many clouds you're using today. Just a quick poll, throw in a question, and just let me know how many clouds your organization is using today that you're aware of. I think that's the other fun one, is that we actually, at a previous organization that I worked at, we used a tool to actually see how many cloud or SaaS services we were using. And the number shocked pretty much everybody. was one of my favorite things. No one was able to actually able to say where all these came from, but there were over 100 different various services that people were using and going out to the cloud for. So those are the sorts of things you may only know that Azure or AWS is there. There is one question here. I think you answered it already. Yes.
Really quickly, could you stop sharing your screen for a second?
Sure.
Yeah, just so that I think what it is the screen sharing covers the question and answer. It might be easier for you to see, but don't worry. I'm currently pushing that same last slide that you had with all the resources.
Okay.
So sorry to interrupt. Go on.
No, it's fine. Yeah, I mean, we had like over 100 cloud services that were in use. I see somebody here says 2. Thank you. The interesting part to me is I'm not sure that I'm not sure. I know that we use at least 60% cloud for us. I think the interesting part is how many of you are having success managing across all of those clouds, and how much of this is just looking at bills and wondering where it's all coming from. I think that's the much more interesting part, and something that we see from a lot of customers is that the ones that have gone out and done cloud, what's the top thing that makes Expedient better than our competitors? It's our people. Our technology stack is a VMware powered stack, and a lot of people can run a VMware powered stack. You're probably running one in your data centers today. We have incredibly smart people that deliver this day in and day out for over 1,000 customers. And our people are what make this go. We have a top-notch support organization, an incredible delivery organization that makes sure that our customers are successful. We want to make sure that our customers are happy, that our customers are getting what they need from this from a cloud operating model. And I think what a lot of times they meet our people, they hear our story, and they go, "Oh, I didn't know something like this existed." And we need to really understand. We really want to make sure that our customers have the best experience possible. And I think our support and delivery organization do a fantastic job of that. Thanks for joining us. Someone who's leaving. Managing the cloud through great protocol. I think the interesting part of managing that through protocol, that involves sitting down and really taking the time. And it sounds like you've done a great job of really taking the time to get everybody on board with how this actually, kind of needs to work. I think a lot of organizations here, some, CIO director level say, we want to be cloud first. And then that's where it stops. They don't dig any further. They don't go any further. And that can be a really big problem because they're not actually figuring out what they really need to do. Processes may need to change. Technology stacks may need to change. Maybe organization needs to change in order to be able to support this fully going forward. So congratulations to you that you actually took the time to build a good protocol to make this all work. I see a lot of organizations that don't do that part, and they end up with a bunch of stuff in AWS that they feel like they're overpaying for. But it's interesting that a lot of people are using more than one cloud here. When you say 60%, and this is just a question to a specific person, this 60%, does that mean your IT is 60% cloud, or are you using more than one cloud to meet that 60%? That seems like a really weird question, or a really weird way to ask that question, but just trying to gain some knowledge on that one. Real quick, I realize now that in order to see the Q&A, we can't show can't show screen.
You can pop it back open. I just want to let everyone know, if you do want to ask a question, you need to minimize the shared screen. AJ, you can go back to sharing your screen if you wanted.
Sure.
I just wanted to make sure everyone knew where it was.
More than one cloud. Okay, good. Thank you. One of the things that we're working on today is our cloud different. This is actually we're building out a multi-cloud platform to be able to support this. So we want to take this further and out to the edge. because we know that a lot of customers are really, trying to figure out how to do cloud going forward. We've actually seen that there was a stat that came out that cloud's been around for about 15 years now. EC2 started in 2006. By the way, that's how old Amazon EC2 is, 2006. And when we're out there going through this, we find that a lot of customers are still not fully there yet, right? Only 16% of customers who responded to a poll said that they were 100% cloud. So we're sitting here going, it's been out there for 15 years and only 16% have made it 100% of the way there. Why? What's really driving that? I think there's a lot of times where, people want to go out and build these sorts of things, but they don't know how to do it. In fact, 83% say cloud is going to be their primary venue by 2022, but 85% of people say that they don't have the skill set to do this. This doesn't add up. So what we want to do is help customers do this. So that's where our multi-cloud universal services come in, to be able to deliver a number of services across the board. Automation just happens to be one of them. So being able to support Terraform and Ansible and plug into your developers, models, I think is actually really, really important. But building this out at a bigger level from a container standpoint, VMs, DR, how do we actually deliver more of that going forward? I think just another quick poll here. How many of you work with your developer teams day in and day out? And how many of you talk to them occasionally? I think that's something that we run into a lot, is that we find that the infrastructure team is finding out that the developers went to AWS, went to Azure, and are driving the hyperscale side, and the infrastructure team is trying to figure out how to deliver on top of that. So I think there's a lot of interesting points there. Occasionally. So when you say occasionally, kind of walk me through that. I see, we have some people out in the audience that, I see a lot of system administrators. So how's everybody kind of handling, day in and day out? Good. I'm glad that there's I see occasionally speak, day in and day out. For the person who said day in and day out, how does that relationship work? Is it more of the infrastructure team is dictating what goes out to the developers, or the developers dictating how infrastructure is supposed to be deployed? How does that work? And then for the people who say, occasionally, is it just whenever somebody needs something and that's it? Or is this something that you do going forward? I find that this answer is usually, it's a very interesting answer, because I think a lot of times it's either it only happens occasionally or it happens all the time. There's no gray area in the middle. Work in tandem. We do not subscribe to a standard solution. That's good. I think there's the give and take of that can actually be really great. When something is needed, yep, a lot of when something is needed. I think building more of a rapport between the two is where these sorts of automation solutions can succeed. I think being able for the infrastructure team to enable the developers can be a much more fruitful relationship going forward. Usually when the need arises, occasional meetings throughout the week, they try to dictate, we regulate, and answers are, yes, these are all fairly common answers. These all feel great. I feel like I'm having some feelings of my past experiences here. When you're dictating, when dev tries to dictate, what do you mean by that? They want to say this is how it needs to be, and you have to be the bad guy to say that's not how this works from an audit standpoint. How does that work for the person who asked that? Is there do you feel, for the people who said occasionally, do you feel a need to do it more often? Does it feel like it would be better doing it more often, or is this just a very transactional relationship that happens between the two?
AJ, it's in these long pauses you realize there is a little bit of a delay.
Yeah, I do, and I appreciate that. I mean, this is all a system sort of thing. It's very interesting. Obviously, people have to type. Typing
Oh, of
takes
course,
time.
of course, of course.
And then there's the delay between the audio and that. So that's fun.
Great, but I'm loving this interaction. So keep going, keep going.
Yeah. I'm going to wait for some responses here, but I do appreciate this kind of back and forth between the participants. I do appreciate this. This actually means a lot to get all these kind of questions and answers in. I think the dictation needs to be what can I do to get with the test drive? What software is provided? So if you go to expedient.com/VMware-test-drive, you get access to our platform, which is a fully VMware powered platform. So that's ESXi on the bottom, vCenter, Cloud Director, NSX, and you have the ability to build VMs and build your workloads inside of that. Do things like distributed firewalls and microsegmentation, see the performance of the platform, and see how to build without having to think about the infrastructure that's on the back end. So again, expedient.com/VMware-test-drive. You can go to our website as well to find that. I would say that if we ever get to go back into the office, reaching out to your developers, have lunch with them, talk to them, build a rapport with them, make it less transactional and more of a relationship that you actually have. That can be really, really powerful as you go forward, especially going from a on-prem or VM environment to a multi-cloud environment. They're going to be the ones wanting to drive the overall cloud model, and I think that's actually a really powerful thing to be able to say, and have that relationship going forward, so that you're all on the same page for things like. I think a lot of times developers want to do everything. They want to have the full control. They want to have the this is the way we want to deploy it, and then you say, okay, cool. Here's our processes for adding user accounts to things that has to pass audits. Are you okay with that? And then they go, oh, yeah, we don't want to do that part. That part's very boring. And they don't want to do that. And neither should you, right? So how do you help them? How do we help build authentication platforms going forward that meet the processes, that meet the audit needs, that meet the compliance needs of organizations, so that everybody goes home happy? Auditors are happy, developers are happy. There's not a bunch of double work to back in a process for doing all of this. You want to build it right the first time, and I think that's actually the way to go. And I'm interested to see from people who are using like 4 clouds how you're handling authentication and those sorts of processes.
Yeah, AJ, at this point, I would take I would get lunch with anybody, not just the developers.
Yeah, I mean, I would love to have lunch with a lot of you right now. It's been almost a year now. And I'm really thankful that, all of you have joined us for webinars. And I'm sure some of you have been on our webinars before. We've appreciated all the time that we've gotten to spend with everybody this year. And I think hopefully we can do some more of these in person. We can see faces instead of just names in a chat box.
Yeah, that'll be happening soon. I have good confidence in that. Well, with that, I have to just say thank you, AJ, for taking the time to speak with us today. As a reminder to our audience, you will receive a follow-up email with the on-demand link from today's webcast. To find out more about the VMUG webcast program, visit vmug.com and check out the education page. Please make sure to complete the short online evaluation that will pop up as you exit the webcast and let us know how today's session went. I just got to say, it's great seeing a lot of the same names and faces out there. So not faces so much, but all the names. And I can't wait to see you guys in the next one. We don't have any left this week. We have a couple next week. So keep your eyes out. And then April is very busy. We have a lot of webcasts coming up. So again, thank you so much, AJ.
Oh, thank you, Drew.
All right, great. And from all of us here at VMUG, thank you, and have a great rest of your day.